All right, we are ready for the fifth and final lesson of the week. The lesson today gets a little bit harder than what we've done the rest of the week, but it's not too bad. So we'll work our way through it and see how we do. All right, let me get a pen. Here we go. This lesson is called Problem Solving Investigation, and we're going to work backward, it says. First part here, it says, learn the strategy. Nathan used some flour for a cake recipe. He used 1/4 of the bag of flour for a bread recipe. There is 2/4 of the bag left. What fraction of the bag did Nathan use for the cake? So we're going to work through this and think about what we know and what we need to find out. So first, let's talk about what we know. Nathan used some flour for a cake recipe and blank of the bag for a bread recipe. So what part of the bag did he use for the bread recipe? Well, I can find that in the question up here, and it says he used 1/4 of the bag for the bread recipe. Then it says he has blank of the bag left. Well, if I look up here, it says there is 2/4 of the bag left. Okay. What do I need to find? I need to find the fraction of the bag of flour that was used for the, well, I just got to look up here. What fraction of the bag did Nathan use for the cake? So I need to find the fraction that he used for the cake. Okay. For the plan, it says, I will work backward to solve the problem. Working backward means I'm going to take what I know and figure out what I don't know. Okay. So let's work backward. We know in the whole bag, it's divided into fourths. So for a whole, that means there's going to be 4/4. So one whole bag of flour is 1/4, 2/4, 3/4, and 4/4. Okay. So what portion of the bag was used for the cake? Well, 1/4 was for the bread, which we already knew. 2 of the fourths was the amount of flour that was left. So what did we use for the cake? 1/4 of the bag was used for the cake. So it says, does this answer make sense? Well, by looking at this picture right here, it makes perfect sense because we know that in the whole, if we divide it into fourths, there would be 4 of them. Here is the 1 we used for the bread. Here's the 2/4 that were left over. And so this has to be the amount for the cake. So yes, of course, it makes sense. Okay. Or I could say 1/4 plus 2/4 plus this 1/4 equals 4/4, which then is 1 whole. So that is the whole amount of flour. All right, let's move on to the next example. All right, in our next example, it says, Lily, Noah, and Kaylee are sharing a pizza. Oh, that's neat. We've got Lily and Noah in this problem. Too bad we don't have anybody in our class named Kaylee, huh? All right, so let's start again. Lily, Noah, and Kaylee are sharing pizza. Noah ate 2/6 of the pizza. Kaylee ate 1/6 of the pizza. There is 2/6 of the pizza left. What fraction of the pizza did Lily eat? So let's think about what we know. I know that Noah, I'm going to write his name, ate 2/6 of the pizza. I know that Kaylee, Kaylee, Kaylee ate 1/6 of the pizza. And I know that left over is 2/6 of the pizza. Okay. Now, what do I want to find? I want to find what Lily ate. What fraction? How many sixths did Lily eat? Okay, so plan, I'm just going to go back here and see what they said for plan. Plan, I will work backward to solve the problem. So that's what you write in the plan. I will work backward to solve the problem. Okay, so now I'm going to solve it. And to solve it, I'm going to draw out a rectangle. And do you know how many equal spaces I'm going to divide it into? Well, up here in my answer, it's going to tell me, or not the answer, I'm sorry. Up here in the question, it's going to tell me that I'm dividing it into 6 equal spaces. So 1, 2, 3, 4, 5, 6. I did pretty good that time on keeping them pretty equal. I usually don't. All right, so let's just kind of map out what we know here. We know that each of these is worth 1/6. So I'm just going to write that out. 1/6, 1/6, 1/6, 1/6, 1/6. Okay, so I know that Noah was 2/6. Okay, I know that Kaylee was 1/6. And I know left over was 2/6. Okay, so what do we have unaccounted for? Right here. So who's this one belong to? This one belongs to Lily. So what portion of the pizza did Lily eat? Lily ate 1/6 of the pizza. Okay, down here, does it make sense? Yeah, because we've got 2/6 plus 1/6 plus 2/6 plus 1/6, and that's going to equal 6/6. So if you write that out, 2/6 plus 1/6 plus 2/6 plus 1/6. If I add 2 plus 1 plus 2 plus 1, that gives me 6, and I keep my denominator of 6. It equals 6/6 or 1 whole, so it does make sense as my answer. Okay. All right. So we've got some more practice problems to do, and we're not going to use a whole page like this to figure these out. We might not even have to draw a picture. We might be able just to use our brains to figure these out. So let's look at this. It says solve each problem by working backward. Number 1, make sense of problems. Chloe did some of her homework before dinner. She did 2/6 of her homework after dinner. She has 1/6 of her homework left. What fraction of her homework did Chloe do before dinner? Write your answer in simplest form. So here's what I know. I know that she did 2/6 of her homework after dinner. I know that she has 1/6 of her homework left. I want to know what I'm adding in right here as what she did before dinner. And it needs to equal 6/6, right? Okay, so I know that the denominator of my fraction is going to be 6. So I have to say 2 plus 1 plus what equals 6. So 2 plus 1 is 3. What plus 3 equals 6? 3 plus 3 equals 6. Okay, so that tells me that before dinner, Chloe did 3/6 of her homework. Now, the last thing we have to do, though, is write this answer in simplest form. So 3/6 can be simplified. What number divides evenly into both 3 and 6? 3. 3 can be evenly divided by 3. 6 can be evenly divided by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. Ooh, 2. So before dinner, Chloe did half of her homework. Okay? Do you see how I filled in what I know, left a blank for what I didn't know, and it has to equal the whole, and I know how many's in the whole by looking at my denominator. So let's use that to do the second question. It says a bag of marbles contains red, green, and blue marbles. 1/6 of the marbles are red. 2/6 of the marbles are green. James says that there are fewer blue marbles in the bag than the green. Do you agree or disagree with James? Explain. So let's look at this. If I have 1/6 is red, I'm just going to label this as red. 2/6 is green. Plus this blank is going to be blue. Okay. And looking at my denominator, I know that my denominator is a 6. So my numerator in my answer has to be a 6 because that's how many is in the whole. Okay. So I've got 6 as my denominator. And I'm going to add 1 plus 2, which would give me 3. But I've got to get to 6. So what needs to go in this blank? 1 plus 2 plus blank equals 6. I need a 3 in that blank. Okay, so 3/6 of the marbles are blue, right? James says that there are fewer blue marbles in the bag than green. Do you agree or disagree? Well, let's look at this. There are 2/6 of them are green, and 3/6 of them are blue. When my denominators are the same, I only compare my numerators. So in this instance, 3/6 is larger than 2/6, which means there are more blue marbles than green marbles. So was James correct? No. Okay, James was not correct. So we would say we disagree. Right? We disagree. And this is my explaining here. I didn't really put it out in words, but you can see how we figured that out. Okay? All right, let's move on to number 3. Number 3 says, Brandy and her mom are at a pet store. The pet store has 12 reptiles. Of the reptiles, 2/12 are snakes, and the rest are lizards or turtles. If there are the same number of lizards and turtles, what fraction of the reptiles are lizards? So let's think about this. There are 12 in the whole. I'm going to draw a picture for this one. Okay. There are 12 reptiles. So let's divide this out into our 12 reptiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And it says of the reptiles, 2 are snakes. So I'm just going to section this off as snakes. Okay. And that leaves me with how many blanks left over? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So if we have the same number of lizards and turtles, what fraction of the reptiles are lizards? So if I have 10 animals left over and basically half are lizards and half are turtles, how many of each will I have? Well, what's half of 10? 5. That's right. So 1, 2, 3, 4, 5. So I'm going to section off 5. 1, 2, 3. 1, 2, 3, 4, 5. And I should have 5 more left over. 1, 2, 3, 4, 5. And that's right. So this is lizards. And this is turtles. Okay. So I have it all figured out here. But the question says, if there are the same number of lizards and turtles, what fraction of the reptiles are lizards? So how many lizards do we have? That is our part. We have 5 lizards out of how many animals in the whole? 12. Okay, so 5/12 of the reptiles are lizards. Okay, sometimes you need to draw a picture. Sometimes you need to fill in the blank. Guys, it does not matter how you figure out these answers as long as you use a way that is comfortable for you. Okay, you can see that I've done these a couple different ways. All right, let's move on to the back and finish this lesson. All right, number 4. There are 16 books on a shelf. 4 of the books are about animals. 2 are about adventure. The rest are mystery. How many are mystery books? So let's think about this. How many books do we need in our whole? We need 16, right? So 4 of the books are about animals. 2 are about adventure. And the rest are mystery. So I'm just going to put a blank there because I need to figure out what goes in that blank here in a second. And there are 16 in the whole set. Okay? So I have to figure out what goes in this blank to make this a true statement. 4 plus 2 is 6. What would I add to that to get 16? 10. That's right. So how many books are mystery books? 10 of the books are mystery books. Okay. So I already have my answer kind of circled or boxed off because of the way I wrote this. Okay. All right. Number 5. There are 10 pieces of chalk. 2/10 of the chalk is pink. 1 piece or 1/10 is blue. The rest is white. How many pieces of chalk are white? Well, if there are 10 pieces, that's 10 out of 10. Okay, this is the whole set, 10. Okay, we keep our denominator the same. Okay, 2 pieces were pink. 1 piece was blue. The rest is white. So 2 plus 1 plus what equals 10? 2 plus 1 is 3. 3 plus what equals 10? 7. Okay, So 7/10 of it is white. Now, 7/10 I kind of have circled, but it says how many pieces of chalk are white. I don't want to say 7/10 pieces are white because that means less than one piece. I want to use my numerator to tell me how many pieces that I have that are white. So 7, this is my answer. 7 pieces are white. Okay. All right. Number 6. Giselle played with some friends on Monday. She played with 2 times as many friends on Wednesday. This was 4 more than on Friday. On Friday, she played with 4 friends. How many did she play with on Monday? Now, this is a puzzle and a half right here. So we're going to write out some things to figure this out. All right. So she played with friends on Monday, Wednesday, and Friday. So I'm just going to write out Monday, Wednesday, and Friday. Okay, I'm going to use what I know. Okay, I know that on Friday she played with 4 friends. Okay, that's going to be my starting point because I know this one. Okay, all right, so now let me go back. Giselle played with some friends on Monday. She played with 2 times as many friends on Wednesday. This was 4 more than on Friday. 4 more than on Friday. Okay, so she played with 4 more friends on Wednesday as she did on Friday. That means 4 more than 4. So on Wednesday, I think she played with 8 friends. Okay, so let's go back and look at my question again. Giselle played with some friends on Monday. She played with 2 times as many friends on Wednesday. Okay, so if she played with 2 times as many friends on Wednesday, that means this number is 2 times as many as this number. So 8 is 2 times what? 4. So on Monday, she played with 4 friends. Okay, so Monday, 4 friends, Wednesday, 8 friends, Friday, 4 friends. Okay, how many did she play with on Monday? Well, look, we could have answered any of those. We could have answered Monday, Wednesday, or Friday, but this asks me only for Monday. Now, this question was a prime example of working backwards because it didn't really tell me enough information until almost the end of this question. I had to start almost to the end of the question. On Friday, she played with 4 friends. That was the only thing I knew for certain. So I had to start there and work my way backward to figure out the rest. Okay. Number 7. Mrs. Vargas is making costumes for a play. She needs 3 buttons for each costume. Complete the table to find how many buttons she will need for 22 costumes. So if she needs 3 buttons for each costume, 8 times 3 is 24. 9 times 3 is 27. 10 times 3 is 30. 12 times 3 is 36. 13 times 3 is 39. 20 times 3 is 60. So 21 times 3 will be 63. 22 times 3 will be 66. So it says how many buttons will she need for 22 costumes? So we're going to write 66 buttons. All right, now that's the end of this lesson. You're going to do the homework for some extra practice, and then you're going to do the self-check, which is now in Schoology and not on MyMath. Everybody should be familiar with it by now because I think you've done that much this week. I think that's about it. It's been a pretty good week. I hope we've gotten some things figured out that maybe we didn't know at the beginning of the week. And yeah, I thought about